Hey everyone, it's Mr. Anderson back with the second part of our video here. We're going to move on to example number 3. Hopefully you've watched the first video. If you've not, go back and find the first video in our Schoology link and address that one first. Watch this one second. Example number 3 says find the roots of the equation, and then we have parts B, C, and D that ask us to graph, ask us a question about the zeros and the roots. Let's go ahead and find those roots, and we're going to do so using that factoring process that we outlined on the previous page. All right, we're going to factor this thing into two binomials, x squared minus 2x minus 15 equal to 0. The factors of x squared are going to be x and x, but then I got to know a little bit about the factors of 15. All right, the factors of 15 in this case are going to be 1 and 15, which are fine, but then the alternative factors that we have are going to be 3 and 5. All right, so here we go. We can continue with the factoring. As long as we know that the 2, as the 2 is negative, that makes the larger value negative. And now my question is, which do I use? Do I use 1 and negative 15? Do they add to negative 2? Actually, it's 3 and negative 5. They add to negative 2. So it's going to be x and 3 and x minus 5. That then allows me to solve. Excuse me. Now I can solve and I can say x plus 3 equals 0, and I can subtract 3 from both sides and get x equals negative 3. I could also say that x minus 5 is equal to 0, and I can add 5 to both sides and get x equals 5. All right, we're going to see something pretty neat here in just a moment when we go ahead and do some graphing. And in order to graph here, I'm just going to use the tabling method we outlined in the prior week in class. I'll x, y, I'll add 5 spots to my table. And then in order to do the graphing using the table, it's helpful to identify A and B and calculate the equation of the axis symmetry. A in this case is 1, B is negative 2. If A is 1 and B is negative 2, then what that allows for is using the equation negative b over 2a to get the axis of symmetry. And I'll mark that down here. The axis of symmetry is x equals negative b over 2a, which is negative 2, divided by 2 times 1. And if I work that out, negative 2 is 2, 2 times 1 is 2. That means that 1, right, because 2 over 2 is 1, goes in the middle of my table. All right, count backwards, 0, negative 1, count forward, 2 and 3, and now I can use my graphing calculator with the equation in y1, x squared minus 2x minus 15. That's the equation we're dealing with the problem, and I can drum up a t-table that allows me to graph accurately. All right, so there's my t-table. I see that symmetry in the table. And I'll use red to graph here. Let's see, over 2 down 12. That's going to be a dot right there. Over negative 1, or over 1 to the left, excuse me, and down. You know what? I goofed up. This should not be over 2 down 12. My eraser's not working. Let me try this again. Okay, here we go. It should be over 2 down, or over 1 down 12. Sorry about that. 0 is negative 15, and then over 1 this way, and down 16. And then over 2 and down 15, and over 3 and down 12. That doesn't give me the entire picture. What I always recommend doing in this case is expanding that table on my graph, and if I do so, I can go over 2 and down 7, and I'm just looking in the table for this on my graphing calculator. I can go over 4 and down 7, because I will have that symmetry, but then here's where those roots come in. If I go over 3, the point's 0, and if I go over 5, the point is 0. And golly gee, wouldn't you know it, there's those roots that we just saw in the problem there. Now my parabola is not perfect there. It's kind of hard to draw it on the iPad, but for the most part you can see it going through those points. And now we got some questions that are hopefully going to bring this home. What are the zeros? The zeros are the same thing as the solution. All right, the roots that we just found. The zeros, the x-intercepts, are going to be negative 3, 0, and 5, 0. Okay, and how do the roots of the function compare? Well, the roots are negative 3 and 5, and those are the x-coordinates of the zeros. That's the big deal. That's the big idea. All right, moving on and continuing, a couple more solving problems that I'm not going to go through here because I want to get to this vertical motion model in example number 4. This vertical motion model highlighted here, h of t equals negative 16t squared plus v sub 0 t plus h sub 0. That models the height against time of an object that's been launched or dropped. Let's see, negative 16, the coefficient on the t squared, is due to gravity. The v sub 0 t, that's the initial vertical acceleration applied, and then h sub 0 is the starting height. So we know that in our problem, a ball is hit off the roof that's 48 meters above the ground, and it's hit at a rate of 32 meters per second. So we know that negative 16t squared plus v sub 0 is 32t plus h sub 0 is 48. And we want to know when it hits the ground, so that means the height when it hits the ground is going to be 0. I will then go ahead and, in order to factor this, right, because this is the first time we've seen a coefficient, a leading coefficient other than 1, I got to get rid of it. So I'm going to eliminate it by dividing by 16. Now this and this are going to cancel, and that's what I want. I'm going to be left with t squared there. Then I do a little bit of math. 32 divided by negative 16 is negative 2t. 48 divided by negative 16 is negative 3. And of course 0 divided by 16 is 0. Now I can factor this. And it'll factor just like it did with the x's. All right, t and t. Okay, and now I ask myself, what two numbers are there that multiply to be 3 and add up, multiply to be negative 3 and add up to be 2? Well, the beauty of 3 is it's a prime number. And 3 and 1 are going to be the only options. But which one's negative? Because of the 2 in the middle is negative, the 3, the larger number, has to be negative. Now I can solve. I can say t minus 3 equals 0. I can say t plus 1 equals 0. And I can solve. If I do that, I get t equals 3. I get t equals 1, negative 1 over here. In this case, this is going to be a no-good solution. This one will be a solution. That's saying that the time taken is going to be 3 seconds. The negative 1 is not going to be a good solution for me in this particular problem because I cannot have a negative time value. If you need to, go ahead and pause the video, but if you are ready, and turn the page. Let's check out example number 5 here. Example number 5 has you doing a little bit of speculating, and it's going to involve a diagram, even though the diagram isn't pictured. So let me see if I can help you draw it and then help you figure out the solution and really what it's asking. A mason is getting looks like ready or to install a new 15 by 20 foot rectangular stone patio in a customer's yard. Before he's ready to install, the customer decides that she would like to add an additional 200 square feet to the size of the patio by adding the same distance x to the width and depth of the old patio design. So here's kind of how this is going to break out. All right, here's the patio, and the customer has signed off on a 15 foot by 20 foot patio. All right, that means our area in this case is going to be 600 square feet. Okay, now that's all fine and good, but then the customer comes in with a change order, says I gotta modify this, and I want to add x feet to both dimensions. All right, happens to be the same thing. All right, and what that's going to do is it's going to change the 600 square feet to 800 square feet. Okay, now what is the value of x? Well, believe it or not, we do have enough information as long as we remember that the area in this case of our rectangle is going to be length times width. And I do know that if I started with 20 feet and I added x feet to it, my new length is going to be 20 and x. And if I started my width with 15 feet and I added x to it, my new width is going to be 15 and x, and that's now going to be equal to my new area, 800 square feet. And that 800 again came from the old area 600 and adding 200 more. All right, now in order to do this, and this is what makes this a higher level question, I do have to FOIL. I have to set up a trinomial that represents the area. All right, so 200 times 15 is going to be 600. 200 times x, I'm sorry, 20 times 15 is 600. 20 times x is 20x. X times 15 is 15x. And then x times x is x squared. And of course 800. Now what I'm going to do is I'm going to combine these like terms and I'm going to rewrite it in standard form all in one step. All right, x squared, 15 and 20 make 35x, and then plus 600, and that's equal to 800. Okay, now one of the things that we got to get over in this problem is that it's not equal to 0. So we either need to solve so it can be, we could solve this in graphically and look for the intersection point, but we can't use the zero product property unless it is equal to 0. So I'm going to then subtract 800 from here and 800 from here, because if I do that, those cancel, and I will have 0 on the right-hand side. So x squared plus 35x minus 200 then will equal to 0. Now I have something where my leading coefficient's 1, it's equal to 0, I can factor and solve. So we'll do that here. Factors of x squared, just like before, are x and x, and now I'm looking for factors of 200 that add up to 35, or factors of negative 200 that are 35 units apart, however we want to talk about that. So here we go. I'm just going to make a little list over here. Factors of 200. All right, what are they? Well, obvious one is 1 and 200. Oh, and because the 35 is positive, that means the larger number is going to be positive and the smaller number is going to be negative. So that's why I'm making the 1 negative. All right. 2 and 100, and again the 2 is going to be negative, and then I have 4 and 50, and the 4 is going to be negative. All right, those I know I still haven't found it yet because those are still what do we got, 46 units apart. But the next one, if I divide 200 by 5, I realize that that is 40, and the 5 is negative. Now looks like we have a winner right there, because negative 5 times 40 is negative 200, and 40 plus negative 5 works out to be positive 35. So I know that's what I want here. All right, so there's that. It is factored. Now we have to use that zero product property to solve, and I'll do that. I have x plus 40 equals 0. I have x minus 5 equals 0. Now, quick little bit of math here tells me that x is in this case equal to negative 40. A little bit of math here, if I add 5 to both sides, tells me x is equal to 5. This right here is going to be my good solution. The negative 40 is going to be my bad solution, and here's why. Because if I try to take away 40 units from both sides, both my length and my width are going to be negative, and I can't have negative dimensions. We are going to work on example number 6 on Thursday in class, so save that one, and you are more than welcome to watch this as many times as you need and then pick up with the homework, okay? So if you got a question, you can work it out with a neighbor, or you can save it for me on Thursday when we return. But like I said, we will wrap up example number 6 and move on Thursday. Thanks a lot for your attention. Have a great rest of the day.